I want to do 3 examples of the quadratic formula with you, and I really need for you to stick through me through this whole video, because after we do these 3 examples, I'm going to tie them together to make a big statement. So make sure you watch all 3 examples because they're all 3 different. So let's go to example 1 here. I'm going to solve this by using the quadratic formula. So I'm going to start by putting this in standard form. So I've got to move the 5 to the other side. So 2x squared plus x minus 5 equals 0. And if we tried to factor this one, it wouldn't factor. So we're going to use the quadratic formula. So I'm going to do the a is 2, b is 1, and c is negative 5. C is always the constant term with its sign, b is the number in front of x, and c is the number in front of x squared. So we need to put our quadratic in standard form first. So the quadratic formula says the opposite of the b term plus or minus the square root of b squared minus 4 times a times c over 2 times a. So then I'm going to go ahead and solve, or simplify rather. This is x equals, so what we're actually finding is the solution that works for x. If we went back up here and put that number in for x, we would get 5 for the answer. So I'm going to have negative x equals negative 1 plus or minus the square root, and I have 1 subtract 4 times 2 times negative 5, and if you do that in your calculator, you're going to get 41 over 4. Now, since 41 doesn't factor, it won't simplify, nothing comes outside the radical, I'm going to go ahead and put that in my calculator so I can just get an estimate of what the number actually is. Well, actually, I don't even know that I need to put this in my calculator. Yeah, let's do. Okay, so the top negative 1 plus square root 41 equals, divide by 4. So x is approximately 1.35. And then if you have a graphing calculator, you can hit second enter, and it goes back to the previous problem. I'm going to hit second enter again, so it goes back to this problem. So I don't have to type it in again. And I'm going to put minus there. And then I'm going to hit equals, divide by 4. So the other number that it approximately is negative 1.85. Now, this is an exact number. These are approximations. I'm just going to use my approximation to help me make my graph. So since these are solutions of this quadratic, we know that the solutions tell us what the x would be if the y were 0. So if y were 0, x would be approximately 1.35 and approximately negative 1.85. So we've found the 2 places where this quadratic hits the x-axis. Notice this one hits in 2 places. It has 2 solutions, negative 1.85 and 1.35. Those are the places where it crosses the x-axis. Let's go to example 2. So I'm going to first put it in standard form. So x squared minus x minus 5x plus 9 equals 0. So x squared minus 6x plus 9 equals 0. So let's do the quadratic formula. Let's see here. This one over here was square root 41, right? Okay. And I had 2x intercepts. All right, let's look at this next one. So I'm going to do the opposite of b. A is 1, b is negative 6, c is 9. So the opposite of negative 6 would be positive 6, plus or minus the square root of negative 6 squared minus 4 times a times c over 2 times a. So x equals 6 plus or minus the square root. This would be 36 subtract 36. What is 36 subtract 36? 0. This one gives me a 0 right here. Divided by 2. So what I'm left with is 6 plus the square root of 0 divided by 2, 6 minus the square root of 0 divided by 2. Well, since the square root of 0 is 0, I'm going to get x equals 6 plus 0, which is 6, divided by 2, which is 3, and x equals 6 minus 0, which is 6, divided by 2, which is 3. So notice on this one, I get two answers, but the answer just happens to be the same thing twice. So this tells me that when I graph this, the only place this is going to cross is right here at 3. And then it's going to go over 1, up 1, and so on. So here I got two solutions, but the two solutions just happen to be the same number. So what happened on the left side is I had two x-intercepts, and they were both real numbers. On the second problem, I only had one x-intercept, and it was a real number. Okay, let's go do the third problem. So this one's already in standard form for me. So I'm going to do the A is -1, B is 2, and C is -2. So the opposite of B, so it'd be -2 plus or minus the square root of B squared minus 4 times A times C over 2 times A. So I get -2 plus or minus the square root of 4 subtract, and this is going to be 8. 4 subtract 8 is -4 over -2. So I have -2 plus or minus, and we just learned that the square root of negative is I, so this is going to be 2i over -2. So when we divide, -2 goes in here 1 time, and it goes in here I times. So look at the two solutions we got. What kind of numbers are those? They're imaginary. So since they're imaginary, that's going to mean something about our graph. So here I had two real x-intercepts. So I had two real numbers, two places where it crossed the graph. Here I had one real number, one place where it crosses the graph. This time I have two imaginary solutions. And let's think about what this graph looks like. If I graph it, I know that the vertex is going to be -b over 2a. So it's going to be -2 over -2. So the x-intercept is 1. And then if I plug 1 in here, I have 1 squared, so -1 plus 4 is 3, and 3 minus 2 is 1. I'm going to double check my work there. I'm going to plug this in the calculator. -b over 2 times -1. So I'm going to type that in here just to make sure. -1 squared plus 2 times 1 minus 2. Okay, that's -1. I thought I made a mistake. So the vertex is at 1, -1. So if I go down here and I find the vertex at 1, -1, let's go back and look at our leading coefficient. Our leading coefficient is a -1. So that means that this parabola is going to turn upside down. So you can see how on number 3, example 3, there were no x-intercepts. And the reason there were no x-intercepts is because our solutions were imaginary. Here, two real numbers, 2 x-intercepts. Here, one real solution, 1 intercept. And that intercept just happens to be the vertex. And that's going to be important later when we start talking about polynomials. This one doesn't have any real solutions. Both of our solutions were imaginary. 1 plus I and 1 minus I. So that means we don't have any x-intercepts. So let's go back and look and see what made this happen. What made this one give me two real numbers was the fact that I had a 41 under here. The reason this one only had 1 is because this was 0, and I would add 0 and subtract 0, I'd get the same number. What made this one be imaginary was the fact that I had a negative number under here. So the number under this radical tells us a lot about our solutions. So let's make some kind of generalized statement. When I have the quadratic formula, I'm going to go ahead and blow this up again here so you can follow along. So when I have the quadratic formula, it says the opposite of b, x equals the opposite of b, plus or minus the square root. Now I'm going to leave this blank over 2a. But if we go back up and we look in our examples, that number that's underneath the radical tells us so much about the way our graph looks. This part that's underneath the radical is called the discriminant. The discriminant. And you'll see that word more than once in math. So the discriminant tells us a lot. If this discriminant is a positive number, then that means we're going to have two real solutions, and they are going to be the x-intercepts. So if that number is positive, we're going to have two real solutions, and they're going to be the x-intercepts. If this number is 0, if the discriminant is 0, that means we're going to have one real solution, and that real solution is going to be the vertex. And then lastly is this third step where we had a negative number as the discriminant. And when the discriminant was a negative number, we ended up with two imaginary solutions. And this means there are no x-intercepts. It doesn't cross the x-axis at all. All right, you'll have a chance in your assignments to practice some of these problems and do some discovery with the intercepts. Feel free to go back and watch the video if you would like more examples or more understanding.